Welcome all to the Fundamentals of Electrical and Electronics Engineering, Unit 5, Introduction to Electronic Devices and Digital Electronics, Practical Session, Experiment number 25. Myself, Ranganatha KV, Lecturer in Electronics and Communication Engineering Department, Government Polytechnic for Women's, Bengaluru. In this session, the contents to be covered are the practical part, the title and the aim of the experiment, operators required, circuit diagram, procedure, and the result. The title of the experiment 25 is to connect and test a relay circuit using an optocoupler. Aim is to connect and test a relay circuit using an optocoupler, that is photodiode and a phototransistor. What are the operators required to connect this circuit? PC817 optocoupler, one number, and two 1 kilo ohm resistances, and one diode IN4007, one relay, and two batteries of 0 to 9 volt, and one LED, and one transistor 2N3904. This is a circuit of a relay circuit using an optocoupler. Basically, the optocoupler is a semiconductor device which allows the electrical signal to be transmitted between two isolated circuits. So this optocoupler consists of a photodiode and a phototransistor. See the IC PC817, which is a 4 terminals, pin number 1, 2, 3, and 4. So which is having a photodiode, inbuilt photodiode and a phototransistor. See, the photodiode has been connected between the pin terminals 1 and 2, and the phototransistor has been connected between the pin numbers 3 and 4. When the optocoupler is energized or powered, so which receives the voltage and light of the LED is on. This light turns on the transistor across the pin numbers 3 and 4. The output of the optocoupler will not activate or will not drive the relay directly. So we have used a transistor 2N3904, which is a NPN transistor, to drive. So which in turn, well, see, the pin number 3 of the optocoupler has been connected to the base terminal of the transistor 2N3904. So which receives the current across its base and which turns on, and this transistor drives the relay. See the procedure. Check all the components. See, in any electronic circuit, before making the connections, it is necessary to check all the components just to make sure that whether all the components are working or not, are in good condition or not. After checking all the components, make the connections as shown in the circuit. Then connect +5 volt to the pin number 1 of the optocoupler and pin number 4 of the optocoupler. Provide a low signal to the input terminal of the optocoupler, pin number 2, through LED, and now observe the sound, that is tick tick sound at the output terminal of the relay. So if the sound comes when the low signal is provided to the input terminal pin number 2 of the LED of the optocoupler through an LED, when the sound comes at the relay, so which shows that the relay is driven by an optocoupler. The result, the relay circuit using an optocoupler is connected and tested. Now let us see the practical session of relay circuit using an optocoupler. Welcome all to the practical session of experiment number 25, relay circuit using optocoupler. Optocoupler is a semiconductor device that allows electrical signal to be transmitted between two isolated circuits. This optocoupler consists of a photodiode and a phototransistor. Now let us see in the circuit diagram how the optocoupler controls a relay. This is the relay driver circuit using an optocoupler. So PC817 is an IC which is inbuilt optocoupler having a photodiode and a phototransistor. So PC817 it is having 4 pins, pin number 1, 2, 3 and 4. Between pin number 1 and 2 a photodiode has been connected, and between 3 and 4 a photo transistor has been connected. So when this PC 817 optocoupler is powered, which receives the voltage and LED, that is photodiode, lights off, and which turns on the light which turns on the photo transistor. This photo transistor, the output of this photo transistor or the output of the optocoupler, which will not drive the relay directly, which will not activate the relay directly. Hence, we are using a transistor 2N3904 NPN transistor, which receives the current at its base terminal, so which drives the relay. Now let us transform the circuit onto the breadboard. 7 IC. So there is a asterisk mark. So with the across the pin number 1. So let us connect. So in this is the pin number 1 and this is the pin number 2. This is pin number 3 and this is pin number 4. Now for the pin number 1, let us connect a 1 kilo ohm resistance. Has been connected, and across the pin number 2, let us connect a LED. And for pin number 3, let us connect a 1 kilo ohm resistance. Other terminal of the resistance should be connected to the base of the transistor. Now this is the transistor 2N3904. So when you face the flat surface, see, this is the flat surface. When I place this flat surface towards my face, so this is the collector terminal and middle one is the base, and this is the left side is the emitter terminal. Now let us connect. I am connecting the base to the other end of the resistance, and the emitter of the transistor 2N3904 should be grounded. Now across the collector terminal, connect a positive of the diode. Now the negative terminal of the diode should be connected across pin number 4 of the PC 817. Now this is the relay which I am using, which is having 5 terminals. This terminal and this terminal are the coil terminals, and this is the common, and this is normally open and this is normally closed. Now I will be connecting the coil terminals. Between the diode terminals. So one should be connected across the diode and across the collector or the diode positive terminal, and other one should be connected across the diode or the diode negative terminal or across the pin number 4. Have been connected. Now I am using two power supplies or two batteries. the positive terminal of the battery should be connected across the pin number 4. I'm connecting this across the pin number 4, and the negative terminal of the battery is grounded. And one more battery, the positive terminal should be connected across the pin number 1 through a resistance. That is, other terminal of the resistance connected to the pin number 1 should be connected to the battery, which I am connecting, and other terminal of the battery should be grounded. Now all the connections are over. Now provide a low signal, that is nothing but 0 or the ground. I will be taking a one ground pin here from here to the LED, and observe when the low signal is provided to the LED, other terminal which is connected between the pin number 2 and other terminal is grounded. Just observe when the low signal is provided, so which energizes the PC817 optocoupler, which in turn activates the transistor 2N3904 and which drives the relay. Now observe when the low signal is provided, we can hear tick tick sound across the relay. When the low signal is provided, LED is getting on, and we can observe the sound across the relay. This is how we can control a relay by using an optocoupler. Now let's see the LMS e-content team members. Sri Ranganatha KV, myself, e-content developer, Government Polytechnic for Women, Bengaluru. Sri Harish, e-content developer, Government Polytechnic, Bagapalli. Srimati Shanta C. Mukherjee Hall, course experter, Government Polytechnic for Women, Bengaluru. Shri Wajid Ahmad, course moderator, Government Polytechnic, Immadihalli, Bengaluru. Thank you.